Hey guys, I hope you are all doing well. Welcome to my channel Beloved Academy.
In today's video, we are going to be solving a question on demand function. Don't forget, demand function shows the relationship between the quantity of commodity demanded and the price. So the function is known as the demand function. Here is the question that we are going to be solving. The question goes thus: find the demand function Q equals to function of P, as I told you the other time that quantity demanded is a function of price, if the of elasticity of demand is minus into bracket 5p 5p plus 2p squared all over q, for q is equals to 500 and p equals to 10 naira. Don't forget that the elasticity of demand shows the degree of responsiveness of a demand of a quantity demanded to price. That is the equation that is given to us. Now, before you can proceed to solve this question, you must know the formula of elasticity. The formula of elasticity is given by this equation. Elasticity is Elasticity is given by this equation: the q, change in q over change in p dot p over q. This is the typical formula of an elasticity of the demand. Let's assume that you are given price and quantity of commodity demanded, and you are told to find the elasticity. This is the typical formula that you are going to be using. But in this question, they gave us the elasticity. We are told to find the quantity. We are told to find the demand function itself. So you know that this is the formula of elasticity, and they gave us in the question that the elasticity is what? The elasticity is this minus into bracket 5p plus 2p square all over q. Now, this is the elasticity that they gave us in the question, but we know that the formula for elasticity is the change in Q over change in price multiplied by P over Q. This dot means multiplication. Don't forget, it's not point. So therefore, this does mean multiplication. Now, this is the formula for elasticity, and they gave me that the elasticity of the demand function that I'm told to find is this. The next thing I'm going to be doing is to equate this to this. Do you understand? In economics, the formula for elasticity is given by this, and they gave me that the elasticity of the demand function that I'm told to find is this. Now, next thing I'm going to be doing is to equate this to this. When I equate this to this, then I will solve for my q. Then I can proceed to substitute the value of p and q to get my demand function. Don't worry, I'm going to be solving it step by step. Now, watch this. I can say that the elasticity here is equals to elasticity here. That is, this elasticity E is equals to E. Let me call this one E1 and what? E2. Now, elasticity 1 is equals to elasticity 2. Therefore, I'm going to be taking this equation and equating it with this. So I'm going to be having dq all over dp multiplied by p over q is equals to minus into bracket 5p plus 2p squared all over q. Now, I've already gotten I've already equate. I've not done anything. I only equate the elasticity and this elasticity. Therefore, now in order to solve for my q, first I have to make the q over the p the subject of the relation. If I want to make the q over the p the subject of the relation, let me use something here so that you will not be confused. Now, in order to make the q over the p the subject of the relation, I'm going to have I'm going to divide this. I'm going to divide both sides by p over q, that is by this thing. Since this is a multiplication sign, I'm going to divide both sides of the equation by p over q. So dividing both sides by p over q, I'm going to be having this, of course, divide by p all over q. You see, let me put this very well. P over q. Then divide this also by p over q over p over q. Now this p over q, we cancel this p over q. So I'm going to be having the q over the q all over the p is equals to minus into bracket 5p plus 2p squared all over q divided by, if I divide this side, divided by this p over q, this division sign is what I brought here, this division sign is what I bring here, so divided by p over q also, p still P over Q. So I have this after dividing both sides by P over Q. So I got here. Now the next thing to do is that if this division sign changes to multiplication, the the denominator here will change to the numerator, and the numerator will becomes the denominator. So I will have something like the Q over the P is equals to minus into brackets minus into brackets 5p plus 2p squared 5p plus 2p squared all over Q. Division sign will changes to multiplication sign. So I'm going to be having multiply by the denominator here will come up. So I'm going to be having Q all over the numerator will come down. So I'm going to be having over P. We got it to this point. Now I'm going to be performing an arithmetic here. I want to pay attention very well. You know, I can say that this Q divided by this Q. If I multiply this and this, if I multiply this and this, I'm going to be having this multiplied by this. I'm going to be dividing this. This can cancel this. I mean, the Q can cancel this Q. So I'm left, okay. Now I'm left with P. The Q here, I've cancelled the Q here. So I have my the Q all over the P is equals to minus. Now, I want to open the bracket with minus 5. I want to open the bracket with this minus sign. So I'm going to get minus 5p minus 2p squared all over P. This P will divide this P, and it will also divide this P, because this equation can be written as this. I can write this equation as minus 5p all over P minus 2p squared all over P. The equation here can be this. What I wrote here is also the same thing as it, because when I find the LCM will be what? P. You get it? The LCM will be P. So this P here we divide both P. We divide this P and also we divide this P. That's it. That's how we're going to be having dq all over the P is equals to this P divided by minus 5p. So I'm going to have minus 5 minus P divided by P squared. So I'm going to be having minus 2p. So that will be minus 2p. So the Q over the P is equals to minus 2p. What I'm going to be doing next is to multiply both sides by dp. That is, this equation that you see here is also the same thing as this. I can put one in this place. You know that I can put one in this place. So therefore, multiply both sides by the P. I'm going to be having the Q is equals to minus 5 minus 2p into bracket dp. Have you now seen how I got here? You have gotten to this place. If I want to, don't forget, if I want to eliminate the Q is in differential state. Now, if I want to eliminate if I want to change it from its differential state, I have to integrate such that I will have only Q. And I will integrate with respect to what is inside the bracket. And the variable inside the bracket is P. So I will integrate with respect to P. So therefore, I'm going to be having, and don't forget, from your basic integral calculus, you have, if you are told to integrate, let's assume that you are given x raised to the power of 2. If you are told to integrate x raised to the power of 2, you are going to be having x raised to the power of 2 plus 1 all over 2 plus 1. That is what? X raised to the power of 3 all over 3. Now, you are going to be using the same approach in this place. From your basic calculus, if you are integrating anything, if you are integrating any function, the function will, the letter for this one example, we take the power of 1 and we divide by the power itself. So when you have x raised to the power of n, if you integrate this, integral x raised to the power of n will be the power, we assume is the power, we take the value of 1, you add 1 to the power, so you are going to be having x raised to the power of n plus 1 all over n plus 1. Now, the same approach, we are going to be applying, this is not there, don't forget. We are going to be applying the same approach in this place. The Q equals to minus 5 minus 2p dp. If you integrate with respect to with respect to P rather, Q will be equals to this differential sign will leave the equation. So I'm going to be having Q equals to minus 5. The constant will become like this. P minus 5p now integrate P minus 2p raised to the power of 1 plus 1. Don't forget that 1 is there is an invisible 1 on the as the power of p, that is p raised to power 1 plus the additional 1 that we had, so divided by 1 plus 1. And when you are integrating, you always add a constant, so you are going to have a c or k. You can represent the constant as c or k. Now you've already gotten the, when you got to this point, the next thing is to write this in another form like this: minus 5p minus 2p raised to the power of 2 all over 2 plus c. Okay, now I have q equals to minus 5p minus 2p squared all over 2 plus c. These two can divide these two, so I'm going to be having in here q is equals to minus 5p minus p squared plus c. Now I have this equation. This is my equation. This is my demand function. This is the demand function that I am asked to find. But I cannot leave the demand function as this. I have to proceed to find my constant, which is c. How do I find my constant? Don't forget that in the question they gave us that the value of q is 500 and the value of p is 10. Therefore, I will substitute the value of q. Q is equals to 500 and p is equals to 10. If I want to find my constant, I will first make the constant the subject of the relation. Let me call this equation 1. Equation 1. I will make c the subject of the relation in equation 1. So I'm going to be having q. If this minus p comes to this side, I'm going to be having q is equals to q minus plus 5p plus 5p. If this minus p squared comes to this side, that is plus p squared is equals to c. So I have made c the subject of the relation. The next thing is to substitute the value of my q and p respectively. So I'm going to be having p, c is equals to, don't forget q is 500 plus p is 10, so that will be 5 into bracket 10. For the next one, p squared, that is 10 squared. 10 squared. 500 plus 5 times 10 is 50. So 500 plus 50, that is 550. 550 plus 100, that is 650. C is equals to 650. So I have gotten the value of the constant. I have got it from this equation out. I know the value of q, which is 500. I know the value of p, which is 10. I have gotten the value of the constant, which is what? 650. Now the required demand function with q is equals to minus 5p minus p squared plus 650. So the required demand function is this, but I can rearrange this equation to become like this: q, so that the positive will start. I'm going to be having 650 minus 5p minus p squared. So I can rearrange this equation as this. That is how to find the demand function when you are given the elasticity of the demand function and the quantity and the price.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe. All questions